This film will take you through the use of the scanning electron microscope, or SEM, to examine your samples. The SEM is an expensive instrument and incorrect use will cause damage. If you're in any doubt about a procedure, you should ask for assistance. Before using the SEM, you should have prepared your sample. Samples must be clean and dry before loading. Mount your sample on an aluminium stub using a sticky carbon tab. It's important that the specimen is rigidly fixed to avoid vibrations. The SEM should always be in microscope control before you begin. If it isn't, seek assistance. To start the experiment, press Vent to let air into the vacuum chamber. A dialog box will appear asking you to confirm that you wish to vent. Press OK. Venting will take several minutes and is complete when the word venting changes to idle. Once vented, you can open the chamber door and fix your specimen onto the sample holder. It's essential to set the sample height correctly to avoid damaging the detectors. Ensure that the highest part of the specimen is set to 10 mm with the elephant. The sample height can be adjusted by turning the Z control on the door of the SEM. Clockwise will raise the sample and anti-clockwise will lower it. When the sample height is set, remove the elephant. 10 mm should roughly give you focus, which can be refined later. After carefully closing the chamber door, ensure the SEM is in high vac mode. If it isn't, obtain help from technical staff. Hold the door shut and click Pump. Continue to hold the door until pre-vac appears. The SEM will take several minutes to reach full vacuum. You cannot begin working until VAC OK appears. Once the SEM has reached high vacuum, you must choose a detector. SE is the most commonly used and will work on the majority of samples. Now choose an accelerating voltage. For polymers, start with either 5 or 10 kV. For ceramics, start with either 10 or 15 kV. For metals, start with either 15 or 20 kV. We're looking at a metallic sample, so we choose 20 kV. Now choose a spot size. A low spot size will allow you to see finer detail but will be noisy. A spot size of 5 is usually a good starting point at a magnification less than 10,000 times. Now turn on the beam. When operating, inactive boxes are grey and active ones are yellow. Once the beam is on, a reminder will appear entitled Microscope Confirm Focus. Do not press OK until you've focused the image of your sample. To refine the focus, first press the Video Scope button. A target region with upper and lower boundaries marked by lines will appear on the screen. Set the contrast and brightness to 0, the screen should be black. Now increase the brightness till the oscillating line is on the lower boundary of the target region. Next, increase the contrast until the oscillating line lies between the upper and lower boundaries. The screen should now form a pale grey image, not white. Click on the Video Scope button to close. You can now focus the image using the mouse by holding down the right-hand button and moving the mouse left and right to focus the image. Once the image is sharp, click OK on the Microscope Confirm Focus box. You have now calibrated the Z focus. You can now move around the sample looking for regions of interest using the arrow keys. You can center on a selected region by double-clicking with the left-hand mouse button. The sample we're using for this film has been poorly coated to exaggerate what's seen on the monitor. The features on your sample may not be so pronounced. The magnification of your image can now be increased or decreased using the plus or minus buttons. There's also a drop-down menu that can be used. To produce sharper images, always focus at a magnification greater than you're going to use for imaging. If your image is streaky or smeared, this is because the beam spot is not circular. This can be corrected using the stigmatas. Focus at a magnification of 10,000 times on a sharp feature. Now press and hold Shift and the right mouse button. This activates the stigmatas. Move the mouse left and right to get the clearest image possible. Now move the mouse up and down to get the clearest image possible. Now refocus as normal. Repeat the procedure until you're satisfied with the quality of the image. The final adjustment to make is the scan rate. The speed at which the beam moves across the sample surface is controllable. In TV rate, this motion is very fast, and this mode is best used at low magnification to move rapidly across the sample looking for regions of interest. The image may be noisy, so switch to slow scan 1 or 2 to examine fine features in sharp detail. When you're satisfied with your image, you can acquire a photograph by pressing F2. This gives a single slow-speed scan of the surface. To save this frozen image, select Image from the In-Out drop-down menu. Then, using up to 8 characters, name the image and press Save. To continue imaging, unfreeze the screen by pressing the snowflake icon. When you've finished imaging, turn the beam off and vent the vacuum chamber. When it's safe to do so, remove your sample. Before leaving, press Pump to return the chamber to high vac status, and select the CCD option in the Detector drop-down menu. Do not leave until VAC OK appears.